Hi everyone, welcome to our key activity. My name is Gala.
My name is Joaquín.
My name is Santiago.
And my name is Paulina.
And we're going to talk a little bit about math.
So, the introduction. First, we selected the state of Tlaxcala, and then we looked for two variables, which was the average temperatures and also the 12 months of the year. Then we inserted those two variables into a graphing application called Desmos, and the graph that resulted was this.
These are the data from which we took all our information. This was provided by Conagua, so we know it's reliable.
Then what we did is that after we inserted all those data in Desmos, a equation was given to us, which is the one that is not circled and the one that is in red. Then with procedures by us, we took another equation, which is the one in blue, and we also changed it to be different, and it is a cosine equation.
Well, afterwards, we decided to compare the data of the graphs, and we answered the following questions. So, to what can be attributed the difference between the two obtained temperature models, with the calculated parameters and the model generated by the program, if any? We said that one uses the function sin and the other uses the function cos. And the other question is, of the two previous models, which one do you consider to be better and why? In our case, we think the model with the function sin is more accurate than the one with the cos. It shows a more detailed report of the information. How is the temperature behavior over time? What does the period of the function represent in the present context? Mostly, the temperature stays the same, and if it increases, it's not that significant. Everything stays the same. The period shows the constant of the graph.
These are the parameters we use. Like Joaquin said, we made our own formula that uses cos, different from the one that the program gave us that uses sin. So like, as you can see, they're pretty similar, but the difference is that one is negative and the one is positive. And in the cos one, we use pi.
We also wanted to know, to predict which was the temperature presented in May from 2015. And to know this, we did is that we changed the value of x to what was supposed to be the position of May according to our table. And it was supposed to be the month -7. So after substituting, all we did was the math, and the result was that for the equation we made, the predicted temperature would be 17.55 degrees, and for the one made by Desmos would be 18.23 degrees.
Okay, so some questions to reflect on. So why was collaboration so important in this activity? I believe collaboration in this activity was very, very important because when we were doing the first data table, there needed to be proper communication so each part of the variables would be correct. So what are your strategies to complete the goal? Our strategies was to use our strengths as a team, put them together, and each do a part that would complement our abilities. What did you do when one of your teammates had an opinion? Well, since the activity was quite tricky, if any one of us had an idea of what we had to do, we gladly accepted and we went along. And to achieve the goal, how did you help out? Well, each one of us helped out in a different way, but mine was helping make the graph and coordinating ourselves to put both data variables.
In my case, how I helped the team was helping with the presentation and also giving my opinion in certain aspects that I thought would suit better in the presentation and in the project.
What I did was I gave the function of cost. Well, I gave the first draft, and I put it on this note.
And what I did was to verify the cost equation and also to make the maths for the predictions for the month of May.
So in conclusion, the conclusion is that we came upon was that this form of graphics is extremely important in our day-to-day. With this information, we now know how to predict the future average weather from a cosine or sine equation. We also know how to use graphing applications such as GeoGebra or Desmos that prove prove to us useful in any future axis activity. So yeah, basically that's our activity, our key project, and we hope you had liked it. These are our fonts of information. So yeah, that's all. Thank you very much for watching.